Okay, in this presentation we're going to look at the complement of a set. Now this is a very important concept in set theory, the complement of a set. So suppose we have the universal set, okay, that's just always keep an eye out for things like that, the universal set, such that we have in the universal set 2, 4, 6, 8, 10, 12 and 15. So for each of the sets A, B, C and D specify the complement sets. Okay, so you notice here that we just have special notation for the complement of A. In this case it is A with the superscript C. Now there's other ways of doing it actually. I just think that's very clear. Particularly if you're new to this sort of stuff. There's also A prime, which is just a dash just above it. Okay, but I'll just stick with C. Okay, now so what I'm going to do actually is I have written the answer here for the first one, but what I am going to do is just sort of cross off from the universal set everything that I've included here, just to make it absolutely crystal clear. So 4, 6, 12 and 15. Okay, and what do we have left? 2, 8 and 10. That's the approach essentially that we're going to take. So it's fairly straightforward now from this point onwards. Okay, so the complement of B is, let's exclude 4, 8, 10 and 15. And what we get left with is 2, 6 and 12. Is that right? Yeah, 2, 6 and 12. Okay. And just actually specify it as a set. Okay. 2, 6 and 12. I just made a bit of space there. Okay. So I put it center screen. Okay, so the next one here is find the complement of C. So, we're not including 2. We're not including 6, we're not including 12, and we are not including 15. What do we have left? We have 4, 8, and 10. Complement of C is 4, 8, and 10. Okay, curly brackets there. And finally, I think you get the idea now, but I'll just finish off just for the sake of completion. 8, 10, and 15, that leaves us with 2, 4, 6 and 12. Okay. Okay, so that is the complement of set. Now it's a very important exercise, particularly when you come up to probability later on in your career. The complement of a set has an equivalence to the complement of probability, or the probability of a complement event. Essentially, what I'm trying to say here is that this stuff is well worth remembering. So I'll leave it there.